Hi friends, my name is Nalala Karthik Kumar Reddy. Today telling about implementation queues using an array. Queue temporarily front and array operation insertion deletion display. Queue concept. What is queue? Examples. Queue is a linear data structure in which the insertion and deletion operations are performed at two different ends. In a queue, data structure ended and removing elements are performed at two different positions. The insertion is performed at one end and deletion is proposed to another end. Queue, array and front section principle. In queue data structure, the insertion and deletion operations are performed based on FIO, first in, first out principle. NQ value to insert an element into the queue, DQ to delete an element from that queue, display to display the element of the queue. Queue data structure can be implemented into two ways using array using linked list. Queue data structure can be implemented in two ways using array. After inserting five elements, queue data structure can be implemented in two ways using linked list. Queue data structure using an array. A queue data structure can be implemented using one-dimensional array. The queue implemented using array stores only fixed number of data values. Queue data structure using array. Just define one-dimensional array of specific size of insert or delete the values into that array by using FIFO, first in first out principle with the help of variables front and rear. Initially both front and rear are set to 1 minus whenever we want to insert a new value into the queue, increment rear value by 1 and then insert at the position. Whenever we want to delete a value from the queue, then delete the implement which is at front position and increment the front by 1. Queue data structure using array. Before we implementing actual operation, first follow the below steps to create an empty queue. Step 1 included all the header files which are used in the program and defined as constant size with specific size to declare all the user defined functions which are used in queue implement. Step 3 create a one-dimensional array with a above defined size instant queue size. Step 4 define two integer variable front and rear. The initialize both -1. Therefore, in front equal to -1, rear equal to minus. The implementation main method by displaying menu of operations list and making suitable functions call to perform operations selected by user on queue. NQ operation. NQ value inserting value into the queue. NQ is a function used to insert a new element into the queue. In a queue, the new element is always inserted to its array position. The NQ function takes an integer value as a parameter and inserts the value into a queue. Step 1, check whether queue is full. Rear equal to size -1. Step 2 is if it is full, then display queue is full. Insertion is not possible. And temper the function. Step 3, if it is not full, then increment rear value by 1 rear and set q rear equal to value. NQ dequeue operation. Dequeue of to delete an element from the queue. In a queue data structure, dequeue is a function used to delete an element from the queue. In a queue, the element is always deleted from front position. The dequeue function does not take any values of parameter. Step 1, check whether queue is empty. Front equal to double equal to -1 and rear double equal to minus. It is empty. Then display queue is empty. Selection is not possible. Can terminate the function. Step 3, if it is not empty, then display queue as deleted element there. Check whether both front and rear equal to front, double equal to rear. It is proved when set both front and rear to -1, front equal to rear equal to -1. Then increment the front value by 1, front plus to delete an element from the queue. Display operation to display the elements of the queue. Step 1, check whether queue is empty. Front double equal to -1 and rear equal to -1. Step 2, if it is empty, the display queue is empty and terminate the function. Step 3, if it is not empty, then define an integer variable and set I equal to front. Step 4, display q value and increment I value by 1, I plus 1. Repeat the same until I value reaches to rear. n equal to 5, front equal 0, rear equal to 2. Implementation and coding for Q. Output. Thank you.